Okay, now you're going to be introduced to the number E. Yes, E is a letter, but it represents a number, very similar to how pi is a symbol, is a letter, Greek letter, that represents a number. So sometime, a long time ago, I guess I could have looked it up to find out when, uh, as mathematicians were studying population growth, bacteria growth, even probably not investments, they noticed that there was a relationship, a constant, a proportional constant, and they got it down to this number right here, and it's an irrational number. It goes on and on and on forever. And they went ahead and gave it a name. All right, so when we do growth and decay problems, population growths, bacteria growth, you'll do that in science and in some math. Pharmacists, chemists study medications and how half-lives, growth and decay, and continuous compounding investments are growth and decay problems. So we're going to do this a little bit quickly. For the investment, there is the formula. Remember the letter E, it's on a scientific calculator. It represents this right here. And I'm going to read the problems, and then we're just going to plug it in to the equation. Jimmy invests $1,363 in a savings account with a fixed annual interest rate of 8% compounded continuously. What will the account balance be after 6 years? So what will that total amount be? So let's just set up the problem. So we don't know the total amount, but we know that the initial investment, we know the letter E, we know that the rate is 8% or the 0.08, and we know that it's for 6 years. Well, this is just straightforward. We can just start simplifying. So the first thing that I did is simplify the exponents. 0.8 times 6 is 0.48. The next thing that I'm going to do, remember in order of ops, you've got to do exponents first. So now we're going to plug into the calculator the letter E. So on most scientific calculators, you might have to hit the shift or second button and the natural log button. So you'd hit second natural log or shift natural log, and an E with a caret shows up, and you just type in 0.48 close parentheses, and that gives you an amount. And now you can multiply that by 1363, and you end up with this amount right here. It's about $2,202.71. Now we're going to go to the next problem where you need to find the time. This one's a little bit trickier. So JD invests $6,825 in a savings account with a fixed annual interest rate of 3%, but compounded continuously. How long will it take for the account balance to reach $8,419.85? All right, so we're going to plug all of the parts in. So we already know the total amount, the amount that's going to be after the investment time. We know the initial amount. We know the rate. We don't know the time. So because we can't simplify this right now because of that variable, 6825 is attached by multiplication. So we're going to divide both sides by that. And then once we do that, we have this value right here, the 1.233, and then it goes on, is equal to e to the 0.03t. Well, again, we can't simplify that, so that's when we're going to take the natural log of both sides. And remember, when you take a log or a natural log of something, the laws of properties of logs, this exponent gets put in front. So we took the natural log of the left, we took a natural log of the right, but this exponent, which was right here, just got moved to the front. All right. Now, this natural log e, that's just a value. Well, and actually, if you type in the natural log of e, it cancels to 1, but let's pretend that you didn't do that. You divide both sides by, because it's attached by multiplication, you can divide both sides. Yeah, and I went ahead, I didn't do that. The natural log of e, if you plug that in, it just cancels to 1. They cancel each other out. And what you have left is 0.03t. So we're going to divide both sides by that because it's attached by multiplication. You're going to divide both sides. So you're going to type into your calculator the natural log of that number that hopefully you stored when you did the division up above. Make sure to close the parentheses, and you're going to divide that by 0.03, and you're going to end up with this value. But we're looking for a time in years, 6.999989, and so on, easily rounds and appropriately rounds to 7 years. Okay, let's move on. Now, how do you find the interest rate problems? Well, Wilbur invests $7,345 at an we don't know the interest rate. We just know that it's compounded continuously for 18 years, and at the balance of 18,000 at the end, the balance is $18,065.78. So we plug all of that in, and again, the variable is in the exponent, so we first have to divide the multiplying 7345 to both sides. And when we do that, that cancels. And once it cancels, this amount on the on the left, you'd store into your calculator. And then you take the natural log of both sides again. And remember, laws of exponent, when you take the log of something, the exponent gets brought in front because it would have been right here, but it gets, because of the laws of the laws of exponents, it gets brought down in front. And remember, the natural log of e simplifies to 1, so it cancels. And then you just have a divide problem. 18 is attached to r by multiplication, so we're going to divide both sides by 18. And when you do that, remember when you type this into your calculator, there will be an open parentheses there. Be sure and close it before you hit divide 18, and what you're left with is 0.04999 continuing, so that would round to 0.05, which is 5%. Okay, one last one real quick. We need to find the initial principal. So Mary invests a sum of money, we don't know how much, in a retirement account with a fixed annual interest rate of 6.99%, compounded continuously. That's why we need the letter E. After 13 years, the balance is $15,157.01. What was the amount? So we're going to plug everything in. Well, when we plug everything in, everything's attached to P by multiplication. Well, the first thing that we're going to do, though, before we divide, we can simplify, because we know both those things, we can simplify the exponents. So let's go ahead and do that first. 0.0699 times 13 gives us 0.9087. Now, this whole thing right here is attached to P by multiplication. So we're going to divide both sides by e to the 0.9087 exponent. Do that to both sides. And now, when we do that, those two things cancel. And now you just have to type that into your calculator. So this is what you're going to do. You're going to type in 15157.0 0.01. You're going to hit divide. I do this. I do left parentheses, then I hit the shift, the natural log button, and that pulls up the E with the caret. And I'm going to put 0.9087, and then I'm going to close parentheses, another close parentheses. Then I'm going to, let's see. There we go. And what we find out is the initial investment is $6,109. That's it. That's how you do these continually compounding, finding all of the different things.